Okay, once again, don't solve AP problems by remembering other questions. Just read and solve what's in front of you. The wind chill is the temperature. So wind chill is temperature, degrees Fahrenheit. A human feels based on air temperature in degrees Fahrenheit. So we've got the wind chill in degrees Fahrenheit, air temperature in degrees Fahrenheit, and the wind velocity miles per hour. The air temperature is 32 degrees, and the wind chill is given by this formula. It is valid for these velocities between 5 and 60. Okay, find W prime of 20. So we have a formula for W, so we need the derivative of W first in terms of V. So you could use your calculator, but I believe the test again will be written, so the calculator is invaluable. So I'm going to do this without a calculator. So the derivative of this constant will be 0. And we'd have negative 22.1. That's a multiplying constant. We would bring down the exponent. And then we would have v to a new exponent, like that. And we're supposed to find W prime of a velocity of 20. So we don't have to work anything out, we just have to make sure we've plugged in the numbers. And by doing that, we would earn the point for finding W prime of 20. Oh, we should include the units. So wind chill is temperature, so we're taking the derivative of W with respect to the input, which is velocity. So the units of W are degrees Fahrenheit, and the units of the velocity are miles per hour. So the correct units here would be degrees Fahrenheit per mile per hour. Then it says, using correct units, explain the meaning of this in terms of the wind chill. So, W prime of 20 is, let's see, let's do a Dank's chart first. So, we have the wind chill is the amount. It's a temperature. That's W. Degrees Fahrenheit. Therefore, the rate is going to be W prime. And that's going to be in degrees Fahrenheit per this variable, which is miles per hour. So I would write on my paper W prime of 20 is, got to have the word rate, is the rate in, got to have the units for that, degrees Fahrenheit per miles per hour, it's got to have the units. So W prime of 20 is the rate in degrees per miles per hour at which the wind chill, because W is the wind chill, is this value that I calculated here. Any positive number to any exponent is always positive. That's why we were saying in class all the time that e to any exponent is always positive. This would be positive, but then we multiply by the negative. So because the rate is negative, so over here, when this rate is negative, the wind chill is decreasing. So we need to use that word. So W prime of 20 is the rate in these units at which the wind chill is, got to have the word decreasing, can abbreviate, decreasing at, and then we've got to account for the 20 at V equal 20, and then you have to have the units for that. And all of that would get you one more point. Okay, find the average rate of change of W. The average rate of change of W. So I went to my golden notes. Average rate of change of, not in this case F, but W. So the average rate of change of W is going to equal, right here, W of 60 subtract W of 5, all divided by 60 subtract 5. Let's keep going here. I have a formula for W. I don't have to work anything out, just have to plug things in. So that's going to be 55.6 minus 22.1, plug in 60 for the velocity, exponent is 0.16. Now minus a bunch of stuff, so put a parenthesis, 55.6 minus 22.1, plug in 5, all raised to the 0.16, and it's all divided by 60 subtract 5, just like the formula here. That will get me full credit on that question. So I do want to put in the units. Again, the units of W here are degree Fahrenheit. The 60 and the 5 are units of velocity. So my final answer, I would include those units. And that would get me 1 point. Okay, over the time interval, 0, so time now, not velocity, over the time interval 0 to 4, the air temperature is always 32 degrees. At time equals 0, the wind velocity is 20. I would write that down. Let's see. The velocity at time equals 0 is going to be 20. If the wind velocity, so that's this, the velocity increases at a constant rate of 5 miles per hour. I'm going to write that down. So I'm getting an amount rate here thing. So I've got amount, got the velocity at some time. You know, the velocity at time 0 is 20. Got a rate. The rate here is the rate at which v is changing with respect to time. 5 miles per hour. That's because the units of the velocity are miles per hour. and the units of the time are hours. What is the rate of change of the wind chill? Okay, so they're asking me to find the rate of change of the wind chill. The wind chill is capital W of V with respect to time. So I want dW over dt at t equal 3. That's what I'm trying to find. So again, you must read slow. What is the rate of change in the wind chill with respect to time? Indicate units. Okay. Looks a lot like a dread problem. I'm not sure if it is or not, but as long as I'm writing, I keep going. So I got going on Danica's chart here. That means over here I would have to have W of V. Because I've got dW dt. This place is over here, I got to have W. Says, so that's the D, Danica's chart. I read the problem. I've got all the rates written down that they talked about. That's these two. Need an equation involving the amounts. That's all set up for me as well, because one amount is velocity, the other amount is wind chill, or W. The equation they gave me has both the wind chill and the velocity. So that's W of V is going to equal 55.6 minus 22 V to the 0.16. So now I need to take the derivative of that equation with respect to time. So this side will become dW over dt. This derivative is 0. 22, so I left out the 0.1 there, sorry. 22.1, fix that. Bring down the 0.16, raise to the 0.16, subtract 1. Now, because previously here in part A, we were taking the derivative with respect to an input variable of v. So over here, we would have ended with a dv over dv, like that, which is equal to 1. Here we're taking the derivative with respect to time. So we end up with it, when we take the derivative of the v, we get a dv over dt. Oh, I messed up here. I left out the v. Hold on. This one, when using the power rule, bring down the 1/6, and you still have v to the 0.16 minus 1. Then you have dv over dt. There we go. Okay, so now I have my formula for finding dw dt. I need to find that at time equal 3, because that's what was asked in the problem. So that's going to equal negative 22.1.16. I need the velocity right here, the velocity at time equal 3. This is where I think I would have gotten stuck on the problem and would have had to have moved on. Just give up the points because I don't want to get stuck. I want to keep moving. But what was tricky is they told us the velocity at time 0 is 20. They also told us the velocity goes up by 5 miles per hour every hour. So that means we're starting at something like this. We've got our velocity and we've got time. And that chart's backwards. Let's go the other way. So we've got our time and our velocity. Time 0, velocity is 20. Time 5, Time 1 hour, the velocity would be 25. 2, the velocity would be 30. Therefore, at hour 3, the velocity is 35. And then dV dt is always 5. And you can stop there, other than we do have to indicate the units. So the units for W are degrees Fahrenheit. We figured that out earlier over here. The units of W are degrees Fahrenheit. The units of time are hours. And I would get, so the way the points were awarded on this one is they gave 1 point for actually recognizing this. So that earned me a point. If you didn't have that written down but you later used it correctly here, they would still give you that 1 point right here. The second point was for knowing that this needed to be 35. So that was another point. And then plugging it all in correctly into this formula and having the correct units, that was the third point. So a total of 3 points. Okay, let f be a function defined on the closed interval, -5 to 5. F of 1 is 3. The graph of f prime. So this is f prime. Okay. For the -5 to 5, find all values of x at which f has a relative maximum. So f, when f changes increase to decrease, that's a relative max on f. So that's when f prime is changing from positive y coordinates to negative y coordinates. So that is occurring right here. The y coordinates of f prime are positive. Now those y coordinates are negative. Similarly here. So all I have to write on my paper is at x equal -3 and x equal 4, f prime changes positive to negative. So f has relative max at x equal -3 and x equal 4. Okay, on the actual AP test, they gave 2 points for this, but again, trying to make these practice tests a little more challenging, we're going to say that was worth 1 point for having what you see in green. Next one. So it's for the same time interval. Find all values of x, which the graph of f has a point of inflection. So f, when f changes concavity, that's when f has a point of inflection. So we're looking for when f prime changes increase to decrease or vice versa. That's here, here, and here. So that's what I write. At x equal -4 and x equal 2, f prime changes increase to decrease. So, let's keep going here. This is on the back of the golden notes. You can copy one of those statements. At x equal -1, f prime changes decrease to increase. So f itself has inflection points at x equal -4, -1, and 2. Again, on the actual AP test, they gave 2 points for this. Again, making this problem this test a bit more challenging, we'll say that's worth 1 point. Find all intervals in which the graph of f is concave up and also has positive slope. So f is concave up when f prime is increasing. So I only need to pay attention to where f prime is increasing. Where f prime is increasing. And f has positive slope. Okay, the values of f prime are the slopes of f. You don't have to write this, I'm just doing it so you'll remember. So when this f has a positive slope, would be when f prime has positive y coordinates. It's going to be here and here. Oops, not there, back up. Here. So those are the only two intervals when f is both concave up and has positive slope. So I have to write that down now because it said to explain my reasoning. So I would say f is concave up when, oops, hello. Well, sorry for the interruption. Somebody stopped by. So anyway, f is concave up when f prime is increasing. F has positive slope when f prime is positive. These are both true. For, and then we just list the intervals. So it would be -5 to 4. Sorry, -5 to -4. And 1 to 2. And this time, 1 point if you have the correct intervals, and 1 point if you have the correct explanation. So a total of 2 points. Find the absolute minimum value of f over the interval. Absolute minimum value. So we're going to follow this procedure again. Finding absolute min in this case of f is the process of eliminating candidates. Okay, step 2. The absolute min of f is always located at a critical endpoint of f. Step 3. Critical point of f is where f prime is equal to 0, or f prime is undefined. This is f prime. So if I write on my paper here, step 4, f prime of x is equal to 0 at x equal -5. That's also an endpoint, so it's accounting for 2 things there. -3, 1, and 4. Right there they'll give you 1 point for doing that. And now I've identified all the candidates because this is an endpoint. These are places where, these are x coordinates where f prime is equal to 0. The other endpoint is also a possible candidate. So for this problem I have 5 candidates. And as described in this big box below, if I want candidates, if I want to get all the points on this problem, I have to eliminate 4 of the 5 candidates. And I can eliminate them using words, or I can eliminate them using integrals. So that's what's described here. So we found how many candidates we have. The grader is going to expect us to eliminate, same as this, 4 of the 5 candidates using words or using integrals. So we're looking for the absolute min. So therefore, this spot, which is a relative max on f, and this spot, which is a relative max on f, I don't have to worry about those. So that helps. Let's copy this over. I won't have to worry about let's do some words here and then it'll explain. So in the earlier part, we already identified x equal -3 and x equals 4 as being a relative max. So we can just reference that. We don't have to redo the work. So let's clear this off. Let's move this out of the way. Delete that. Now, wait a minute. I'm going to need that f of 1 equals 3 probably, so let's write that down. Remember, justifying and finding the absolute max can take some time, so be a little careful if you start to feel that you're taking too much time. You don't want to get stuck, you want to just move on. Okay, so words. X equal -3 and x equal 4 are relative max of f. So that's enough that the grader won't care about those 2 candidates any longer. Now I only have 3 candidates remaining. And what I notice is, let's see, for I'm going to have to test all the other candidates because f prime is initially positive. When f prime is positive, f is going up. So if I were trying to sketch what f might look like, I would have an x-coordinate of negative 5. I'd have the value of f at that x-coordinate. And then f would go up because f prime has positive y-coordinates. Then f turns at x equal negative 3. Now because f prime has negative y-coordinates, f is going down. So we get here to x equal 1. Then f goes back up again because f prime has positive y-coordinates. So f is going to go up until we get to here, x equal 4. And f goes back down because f prime has negative y-coordinates until we get to x equal 5. So there really are still 3 places where f could be lowest. So this is why finding the absolute min sometimes goes quick, sometimes not so quick. At this point, I have earned, however, 2 of the 3 points. Because I earned 1 point for this, and then over here, the grader sees this work for f. The grader will see that I'm checking the endpoints, and I'll get another point for that. It's the last point that becomes challenging, because we've got to go find f of negative 5. We also have to find f of 5. Check the problem again. We're supposed to find the absolute minimum value. That means the y-coordinate, the absolute minimum value of f of x. So one of these 3 values will be lowest. Either this will be the lowest, this, which we know is equal to 3, or this will be the lowest. One of those 3 is going to be the lowest point on f. So we're down to the last part, which is to do integrals. We have a graph of f prime, so we're going to use the fundamental theorem to do this. So we can clear this off and get rid of the box now. Get rid of this. Okay, so the fundamental theorem says if I integrate from, we'll say, negative 5 to 1, f prime, that integral must equal f of 1 subtract f of negative 5. This provides a method so I can find f of negative 5. Rearranging, I'm going to get f of negative 5 must equal f of 1 subtract the integral from negative 5 to 1 of f prime. So f of negative 5 will equal, f of 1 is 3 minus big parenthesis here. Okay, starting at x equal negative 5, all of these values of f prime are positive, so all of that area counts positively. It's a half circle, so it's pi. The radius of that circle is 1. That gets squared, but it's a semicircle, so we divide by 2. Plus, now for all of these x coordinates, the values of f prime are negative. It's another half circle, this time radius of 2. So they count negatively. It's a half circle again. So that's the value of this integral. That's the value of f of negative 5. I have to compare that against f of 1 to see which one is lower. So I am going to have to do a little bit of math here. Well, Yeah, we're going to have, let's keep going here. So this is going to be 3 minus, this is just pi over 2. This would be 4 divided by 2. 4 divided by 2 is 2. So that's minus 2 pi. But distributing the negative, you get this. 3 minus pi over 2 plus 2 pi. So that's positive, that's not very negative. Therefore, this is definitely bigger than this. You don't have to write anything about it. That's sufficient just to show that on your paper. So next, I've got to go find f of positive 5. So the integral from 1 to 5 of f prime must equal f of 5, subtract f of 1, rearranging. This time f of 5 will equal f of 1 plus the integral from 1 to 5. So this is going to equal 3 plus, parenthesis, from 1 to 4, f prime is positive. So all that area counts positively. It's 1 times 2. And then half of that again because it's a triangle. Plus 2 times 2, and half of that because it's a triangle. This portion of f prime has negative y coordinates, so that counts negatively. So it should be minus 1 times 1 divided by 2. I don't really have to do a whole lot of math to notice that this is going to be larger than 3 as well, so that's a sufficient amount of work. I can now just write the absolute min of f is f of 1, which equals 3. And that will give me the last of the 3 points on this problem. Consider the differential equation, find second derivative. So going to work here, so you got the second derivative. It's going to equal derivative of 1/2 x will just be 1/2 because we're differentiating with respect to x, plus dy dx minus 1. Therefore, rearranging, oh, see, they want it in terms of x and y, so I can't leave this. So what I have to do is come back over here, plug this back in, because that's the same as this. And then it's all minus another 1 right there. If I get this far, they'll give me a point. Algebraic simplification is not required. So if I get, just checking this real fast. So I actually would have lost both points on this one. I got a little distracted. The derivative of this has to be 0. So then when we plug back in, there's no extra negative 1 there. And that would have gotten me, earned me the second of the point. So 2 points there as well for this problem.